பேசுங்க.
Good afternoon, my dear participants. I heartily welcome you all to the 5-day faculty development program on algebraic structure organized by Research Department of Mathematics, Nesamani Memorial Christian College, Martanda. Now we are getting into our last day of our program. So all the participants are requested to mute their mic. First of all, I would like to invite Dr. T. Shaila Isaac Mary to welcome the gathering.
Good afternoon, everyone. It's my pleasure to welcome you all to this 5-day faculty development program on algebraic structures organized by the Department of Mathematics, NMC College, Martanda. We are honored to have Dr. M. Velrajan, former Associate Professor and Head, Department of Mathematics, Adityanar College of Arts and Science, Tiruchendur, as our chief guest. He is a well-respected mathematician with deep knowledge and experience. We are eager to learn from his talk on the taxonomy of algebraic structures. Sir, we sincerely thank you for being with us today. I also welcome our HOD, Dr. A. Pramila Inbaros, Associate Professor, Department of Mathematics, NMCC, and our program convener, Dr. D. Nita, Assistant Professor, Department of Mathematics, NMCC. We are glad to see participants from various colleges, including our own faculty members, research scholars, and students. I encourage everyone to take part actively, learn new concepts, and share your thoughts during the session. Once again, I warmly welcome you all. Thank you.
Thank you, ma'am. Now I invite Dr. Linda K. Wilson, Assistant Professor, Department of Mathematics, to introduce our today's resource person.
Good afternoon, everyone. It's my pleasure to introduce resource person for today's session, Dr. M. Velrajan, former Associate Professor and Head, Research Center for Mathematics, Adityanar College of Arts and Science, Tiruchendur. He completed his BSc and MSc degree in Madura College, Madurai, MPhil and PhD from Madurai Kamaraj University. He worked in Adityanar College of Arts and Science from 1980 to 2015 and in Sri Sangara Bhagavati Arts and Science College from 2015 to 2023. Dr. M. Velrajan is an expert in the field of algebra and he has 43 years of teaching experience and he has published 18 articles in national and international journals. He guided about 30 students for MPhil and 2 awarded PhD. He has also had the privilege of representing university as a Senate member from 2001 to 2003 and chairperson of the PG Board of Studies, Manonmaniam Sundarnar University from 2012 to 2015. He has also served as a member of the Standing Committee on Academic Affairs, MS University from 2012 to 2015. In addition to his teaching and university representation experience, Dr. Velrajan has held various administrative positions including IQAC coordinator. He also served as the principal of Sri Sangara Bhagavati Arts and Science College. It is our honor to have Dr. M. Velrajan with us today and we look forward to his valuable insights and expertise. On behalf of the Research Department of Mathematics, Nasamani Memorial Christian College, Marthandam, I invite him for the presentation.
Dr. Pramila Imbaros, head of the Department of Nasamani Memorial College, faculty members of NMC College, faculty friends participating from various institutions, research scholars, and my dear students. I am really happy to join with you all, and I would like to thank the organizers for giving me this privilege to share my thoughts with you. Dear participants, just a minute, I would like to share So I hope is the screen visible?
Yes, sir, visible.
Okay. So all of you know mathematics has application in all the fields. But it is unfortunate that many school students have studied mathematics for ages. They are afraid of mathematics. The main reason for this is memorization without understanding the basics of mathematics. And in today's materialistic world, naturally, students are not coming forward to learn mathematics at college level. In Tamil Nadu, recent academic years saw very few enrollments in UG and PG mathematics courses, and many colleges did not hold first year admissions in those courses. This does not bode well for the future. This is not good for the future. If mathematics is learned properly, then no one will have this. So to learn, we have to raise questions. I'm sorry. If learning takes place when the learner has freedom to think, questions arise into the learner and the learner tries to get answers for that. One can also learn by observation and from any incident. Thinking beyond, thinking differently, and asking questions themselves and to others are essential to develop learning. Such mathematical learning should be developed in the students. If mathematics is learned in this way, everyone will start enjoying the beauty of mathematics. Learning mathematics with enjoyment develops critical thinking and creativity. It also makes the mathematics learners to come up, compete, and get remarkable success in any field. Mathematics learners have opportunities in almost all fields. For example, young mathematics learners have opportunities in the field of data science, machine learning, artificial intelligence, operational research, and statistics. But to grasp the opportunities, knowledge and in related disciplines are also essential. For this, of course, completion of additional online courses along with regular mathematics courses is necessary. Whoever the mathematics learners want to become, to sign in that, learn mathematics by understanding, analyzing, applying, and solving mathematical problems. The objective of this talk on a taxonomy of learning algebraic structures is to develop mathematical thinking, problem solving, and thereby developing critical thinking among young mathematics learners. This can be done by enlightening the young minds a way of mathematics learning with understanding and developing interest to explore the beauties of pure mathematics. To learn, we have to raise questions, understand, analyze, apply, explore, and create. And of course, we know how much freedom or how much practice our students have to raise questions. No student will ask questions, but the teachers have to encourage the students to raise questions. Then only the students can learn mathematics. So my talk will be focusing on how to raise questions with students. Of course, the questions have to be raised by the students, but since they have no practice, they have no such practice so far, only the teachers have to initially ask questions so that in future the students or the learner can arise questions themselves. So suppose we learn group theory using topics in algebra, second edition by I.N. Hastings. The definition of group is given like this. And of course, you know, non-empty set with binary operation is a group. If it is closed, associative law holds, identity exists, and existence of inverses. But if you ask our students to learn mathematics with understanding, they say, yes, I understand non-empty set, binary operation. I know what is binary operation. I know what is closed. I know what is associative law. I know the existence of identity element. I know what is the existence of inverse. I understand everything. But this is not understanding this mathematics. Because we know what is a binary operation. By definition, the binary operation on G, if A and B are in G, then there is a unique element S, A dot B, again in G. So that is what binary operation. So if that is a binary operation on G, then why the first condition is given, the closed condition is given? So that question should be arised within the learner of mathematics. So Hastings himself give the binary operation in that way only. If A comma B are there, then S or B also should be there. So in the definition, the first condition is redundant. It unnecessarily given. So we can call G as a group if it is non-empty and dot is a binary operation and the operation is associative, identity element exists and inverse exists. So if the learner himself comes to this conclusion, then the learner can be proud of himself. Then he has to raise the question why the closed condition is redundantly given. And of course, Hastings wants to stress that condition. That is why the closed condition is repeatedly or unnecessarily given. Then the question, natural question to be arised on within the learners are how many identity elements are there in your group? Because by the definition, there is the identity element. Then how many inverses are there for an element in your group? So that question have to be arise within the learners immediately after going through the definition. And of course, we know we can prove that there is only one identity element and there is only one inverse using just the axioms of group itself. And of course, we can prove the cancellation law and the equation Ax equal to B has unique solution, etc. But we have to observe that if we want to prove G to be a group, we have to show that to prove E is the identity element of the group G, we have to show that AE equal to A equal to EA for all A belongs to G. But if we know G is a group, then suppose AX equal to A for element A belongs to G, for single element A belongs to G. Suppose there exists the element X in G such that AX equal to A, then we can come to the conclusion that X equal to E because of the left cancellation law. In particular, if the element, there is the element X in G such that X into X equal to X, then we can come to the conclusion that X equal to E, again by left cancellation. And similarly, to verify B is the inverse of the element of G, to show G is a group, we have to show every element has inverse. So for that, we have to show that there is the element B in G such that AB equal to E equal to BA. But if we know G is a group, to find the inverse of the element A, it is enough to find the element B such that AB equal to E. It is not necessary to verify BA equal to E, because if AE equal to E, then by cancellation law, B is A inverse. This type of observation is useful for answering multi-choice questions. Okay. And we know if G is a group under the binary operation dot, then dot is associative. So A dot B I'm sorry, I have some problem in the system. Shall I share it from my phone itself? Okay, just a minute. Is the screen visible?
Yes, sir.
தெரியுதா? Screen தெரியுதா?
ஆமாம் சார் தெரியுது. சார் ஸ்க்ரீன் இஸ் விசிபிள் சார்.
ஆ?
ஸ்க்ரீன் தெரியுது சார். தெரியுது.
எஸ் சார், விசிபிளா தான் இருக்கு.
இப்ப தெரியுதாங்க ஸ்கிரீனு?
தெரியுது சார்.
ஓகே. லெட்டர் ரீடபிளா இருக்கா?
எஸ் சார்.
ஓகே. So we know if G is a group, the operation is associative. So A dot B dot C equal to A dot B dot C. And we can write it that as just A dot B dot C without any brackets. So though the binary operation says that if A and B are there, then A dot B is also in Z. What we can see is we can extend that to 3 elements, and by induction we can extend that to n elements. So A1, A2, AN are in G, then A1, A2, etc. AN belongs to G. If the binary operation is just multiplication, then instead of dot we can omit the dot and we can write A1, A2, AN belongs to that G. And we can see that for any natural number n, if A belongs to G, then A power n also in G. Since A inverse belongs to G, A power minus n is also in G. So A power n belongs to G for every integer n. And if A1, A2, An are in G, then A1 power K1, A2 power K2, etc., An power Kn belongs to G. If the operation is addition, then A1 power K1 becomes K1 A1. So we have K1 A1 plus K2 A2 plus etc. Kn An belongs to G. So from the associative law, we got this. So this is what is called analyzing in the process of learning. And this way develop mathematical thinking also. And we know the cyclic group generated by n is given by G equal to E is A power 0, J, A square, etc., A power n minus 1, where A power I into A power J is A power I plus circle J, where plus circle is the addition modulo n. So after learning this group generated by the element A, cyclic group generated by the element A, the next question arises is, can we consider any finite set G equal to A0, A1, A2, etc., An minus 1 as a group? For that, the answer is yes. If you are given any set consisting of n elements, if you denote the elements by A0, A1, A2, etc., An minus 1, then we can define the operation Ai into Aj equal to Ai plus circle J, where plus circle is addition modulo n. Just duplicating or imitating the multiplication in the cyclic group, so that we can make any set, finite set, into a group. இப்போ ஓகேவா? இப்போ பரவாயில்லையா?
பரவாயில்ல சார்.
ஓகே, ஏன்னா சிஸ்டத்தில் ஏதோ ஸ்நாக் ஆயிடுச்சு, இல்லைன்னா சிஸ்டத்துலேருந்து டிஸ்பிளே பண்ணியிருப்பேன். இது ஃபோனில் தான் பண்ண வேண்டியிருக்கு, சாரி. Okay. Not only the finite set, we can make it into a group, we can also make it into a ring also. Just by imitating the ring of integers modulo n multiplication, we can make it into a ring also. So we can make any finite set into a group. Okay. Now we discuss how to find the subgroup generated by a subset of a group and the subring and ideal generated by a subset of a ring. So first, So G be a group, A belongs to G. Then what is the smallest subgroup of G containing A? So for that, we take H be a subgroup of G containing A. Then by what we have observed earlier, A power n belongs to H for all n belongs to Z. So the set of all A power n belongs to Z is a subset of H. We want smallest subgroup containing A. So if you take the set n belongs to Z, we can see that that itself is a subgroup of G containing A. Because A power n into A power m inverse is A power n minus m. So the set of all A power n belongs to Z is the smallest subgroup of G containing A. And we call that as the cyclic group generated by A, and we denote that by bracket A. So if we just learn the proof directly taking A power n belongs to Z and verifying that A power n, the set of all A power n belongs to Z is a subgroup of G and it contains A and it is the smallest subgroup, etc. Instead of that, if we go by this way, then this idea will help us to find the smallest subgroup containing any subset of the group G also. If you take G is a group, S non-empty subset of G, then what is the smallest subgroup of G containing S? So for that, again we take H subgroup of G containing S. Then if you take A in S, A belongs to H. Being a group, A inverse is also in H. So A inverse are in H. So by our observation, A1 power K1, A2 power K2, etc., An power Kn, the product belongs to H for all A1, A2, etc., An belongs to S, K1, K2, Kn belongs to Z, and N belongs to N. So that is that all the elements of this type are contained in H, but we can verify that the set of all A1 power K1, A2 power K2, etc., An power Kn, where Ai belongs to S, Ki belongs to Z, and N belongs to N, is itself is a subgroup of G containing S. Therefore, that becomes the smallest subgroup of G containing S. So, if S is a set, the smallest subgroup containing S, S is a subset of the group G, then the smallest subgroup containing S is set of all A1 power K1, A2 power K2, etc., the An power Kn. Now, if the operation is addition, then instead of A1 power K1, A2 power K2, etc., An power Kn, A1 power K1 can be written as K1 A1. So, the group generated by S is given by set of all K1 A1 plus K2 A2, etc., Kn An, where Ai belongs to S, N belongs to N, and K1 K2 Kn belongs to Z. But here, the group operation need not be commutative. That is, the group need not be a abelian group. So the elements A1, A2, etc., An need not be distinct. That is, they may be repeated elements. A1, A3 may be equal to A1, etc. because the operation is not commutative. But if G plus is an abelian group, then the smallest subgroup containing S is given by set of all K1 A1 plus K2 A2 etc. Kn An, where A1 A2 An are any n distinct elements in S. That is, it's a subset of n, and n belongs to n. K1 K2 Kn are integers. We denote that by ZS. Okay. Now the question is, if R is a commutative ring with identity elements, then, and S is a non-empty subset of R, what is the smallest ideal of R containing S? So R is commutative ring with identity. We take, for the sake of simplicity, first R commutative and it has identity, and S non-empty subset of S. Then the question is, what is the smallest ideal containing S? So if you take I is an ideal of R containing S, then we know I plus is a subgroup of the abelian group R plus. So I plus is a subgroup of R plus. But we know the set of all K1 A1 plus K2 A2 etc. Kn An, which we denote by ZX, is the smallest subgroup of R plus containing S, because R plus is a abelian group. So that ZX should contain in our ideal I. But in order that I to be an ideal, for R belongs to R, X belongs to S, Rx should be in I. Since Rx is in I, for R1, R2, etc., Rn in R, X1, X2, etc., Xn in S, R1, X1 plus R2, X2, etc., plus Rn, Xn should be in I. So, our ideal I should contain the elements of the form R1, X1 plus R2, X2, etc., Rn, Xn, where Ri belongs to R, Xj belongs to S, and N belongs to N. But already we have seen ZS should contain in I. But note that we are taking R as a commutative ring with identity element. So, if you take an element ZS, that is for K belongs to Z and A belongs to S, Ka is A plus A n times, that is 1 into A, 1 into A, 1 into A, n times, K times, sorry. If K is positive. If K is negative, then Ka is minus A, that is minus 1 into A, minus 1 into A, etc., plus minus 1 into A, minus K times, if K is negative. And if K is 0, Ka is 0. So, since 1 belongs to R, Ka belongs to Rs. So, Ka belongs to Rs means the elements of ZS, that is K1 A1 plus K2 A2, etc., plus Kn An, belongs to Rs. That is, ZS is a subset of Rs, and Rs is contained in I. So our smallest subgroup should contain both ZS and Rs. Since ZS is contained in Rs, we can take Rs, and we can verify that Rs itself is an ideal containing S. So Rs become the smallest ideal of R containing S. So note the idea we have got from the smallest subgroup generated by a subset of abelian group. Okay. So if you study that smaller subgroup generated in the group properly, we can easily extend that to rings for ideals and of course for subring also. So here, since 1 belongs to R, we have got ZS is a subset of RS. Suppose the ring has no identity element, then what is the smallest ideal containing R? Containing S and contained in R. For that, because 1 belongs to R, we have got ZS as a subset of RS. But we have noted that both ZS and RS should be containing any ideal containing S. So the natural smallest set containing both RS and ZS is RS plus ZS. So we consider RS plus ZS. And we can verify that RS plus ZS is an ideal containing S. And it is the smallest ideal containing S. That can be easily verified. Now the question is, what happens if R is a ring without identity element? That is, R is not commutative. In the previous two, we have taken R as a commutative ring. But if R is not commutative, what happens? So then also RS plus ZS should contain in any ideal containing S. But RS plus ZS will not become an ideal. It becomes only a left ideal. So we have to consider of the multiplication of the elements of R from right. Since we have RS, it becomes left ideal. So for right ideal, naturally we have to add SR. But it has to become ZR. Also we have to add RSR because both side multiplication, both left and right. So we have to consider RS plus SR plus RSR plus ZS. And we can verify that it is an ideal containing S and it is the smallest ideal. That is, this ideal contained in any ideal containing S. So it is the smallest ideal of R containing S. But if identity element is there, then the ZS plus ZS is not necessary because in that case, ZS is a subset of RS. So if identity R is a ring with identity element and S is non-empty subset of R, then RS plus SR plus RSR is the smallest ideal containing S. In a similar way, we can find out what is the smallest subring of R containing S. So for that, this ZS is not sufficient. We have to consider this set, the set of all elements of the form sigma I equal to 1 Tm Ti or Li A I1 K I1 into A I2 power K I2 etc. A I N1 power A K In1 where M Ni are in N Li belongs to Z. So that is just that K into A1 etc. that is not sufficient. We have to take sigma I equal to 1 Tm. So if we take that set, then we can see that it is the smallest subring containing S. If we have this experience, then we can very easily find out what is the smallest subspace of a vector space containing S, if S is non-empty subset of V. So that just if you take set of all alpha 1 x1, the linear combination, finite linear combination of elements of S, then that becomes the smallest subspace of V containing S. So any similar way of learning by understanding the concept thoroughly and applying the learned concept properly, thinking and imagining mathematically makes one to love and enjoy mathematics. And if you learn from even standard textbook, you should not take it for granted. You have to apply your mind and you have to see the validity of what is given there. For example, again in Hessian, in the unique factorization theorem, so in the unique factorization theorem given in Hessian, you can go through the book. There is a small printing mistake is there. And you go through and you understand each and every step. And if you are able to find out the mistake there, then it is good and you are learning properly. It means that you are learning properly. So printing typographical error is everywhere, even in standard textbooks. So don't take it for granted the materials given in any standard textbooks, not only standard textbooks, but also in any open resource material. Be careful and you verify yourself. And if you learn mathematics in this way,
Sir, your face is now visible, sir. Your screen is not visible. Your PPT is not.
Okay. Screen is not necessary now.
Yes, sir.
Okay, I come to the end.
Okay, sir. Okay, sir. Thanks.
So that is why I asked the participants to go through the Hessian book and find out the mistake by themselves. Small mistake. Okay. So if you learn mathematics by understanding this way, or if you make the students to learn mathematics in this way of understanding by raising questions, okay, then they can come up their life and they lead a successful life. And if you make your students to think mathematically in this way, you will become a successful teacher. And if the learners develop their learning in this way, and they can understand that when they study semi-groups. So it is nothing but in group, some of the axioms are dropped. So every group will become a semi-group, but semi-group will not become a group. So we have more results in semi-groups, which we will not get it in group. Similarly, when they study near rings, by understanding that near rings are rings but with omitted axioms. And if they learn modules, it is just generalization of the vector space over the field to just vector space axioms to over a ring. Then they can themselves develop more results in models. They can understand the models in a better way. And the questions, if they think binary operation means if A comma B are in G or A comma B are in G, then there is a unique element A dot D belongs to G. That is what we call binary operation. Now if they write question with themselves, why single element? We have to associate single element with A and B. Why can't we can associate two elements or three elements or in general a subset of that G? Suppose dot is a binary operation on G, then we know if A and B are in G, A dot B is in G. Single element A dot B. Instead of single element, suppose there is the operation which associates with A and B with several elements of that set, then that is called the hyper operation. So a hyper operation on a set S is, it has to associate with two elements, A comma B in S, a subset of S, not single element, a subset of S, any subset. Then that is called hyper operation. So natural theories on hyper semigroups, hypergroups, hyperrings are there. Then coming to the fuzzy structure, once the fuzzy set is defined for uncertainty, that is a set, we know what is a subset of a set. Subset means if we given an element, we have to see whether the element is in that or not, a set means. But if you have uncertainty, if you give grade between 0 to 1, they call that as fuzzy sets. Once fuzzy sets are squarized, our algebraic people went on study fuzzy algebra. So if we apply our minds in this way, we can easily enjoy the development of mathematics, and you yourself can develop more interesting area of mathematics. So my request to the teacher participants is make your students to understand the subject. Make your students to analyze what they are learning. Make your students to write questions and get development. Only that will help us to have a better mathematics world in our country. That will help us help the future. So, because as I told in the beginning, the students' willingness to join mathematics course is decreasing. So, it is the alarming status. Teachers have responsibility. Teachers have to make this situation to set right. to attract more students in mathematics. Only mathematics people, if they learn mathematics properly, they can shine in any field. So to have a bright future, we have to develop mathematics learning. So with this request, I once again thank the organizers for giving me this opportunity, and I thank all the participants for their patient hearing. If you have any questions to raise, you can raise the question. I'm ready to answer to your question.
Thank you, sir. Thank you for your nice presentation. Now the participants can ask questions if they have doubts.
And
Yes,
okay,
yes, sir.
so for the participants, I have created a block, Velrajan M. .blogspot.com.
Okay, sir.
There, I have posted about 40 posts,
Okay, sir.
and in that you can find the material what I have discussed with you. Not only that, but also materials for net set examination and materials to kindle mathematical thinking.
Sir,
So,
will you please share that link to our department HOD? She will
okay,
post in FDP group.
okay, thank you.
Thank you, sir. Thank you so much. So today we come to end of our session. Now I would like to invite Dr. A. Pramila Inbaros, Research Department of Mathematics, Nesamani Memorial Christian College, to deliver today's vote of thanks.
Honorable resource person of the event, respected professors and participants of the program, good evening to you all. I feel honored and privileged to get the opportunity to propose a vote of thanks on this special occasion. A big thanks to our correspondent and principal ma'am for giving the administrative approval and providing us with all necessary facilities for the smooth functioning of the program. Abstract algebra is one of the branch of mathematics which is a study of algebraic structures. There is a unique method in learning and understanding these structures. Today, our professor excellently explained the way of learning groups, rings, and their elements by asking proper questions. Respected sir, your presentation is very excellent and very useful to all of us, including students and professors. Our dear professor was my supervisor during my research period. Sir's knowledge in the subject is very excellent. Sir will be always there in giving continuous encouragement, support, guidance, not only in the academic side, but also in my personal life. Respected sir, your thoughts and words are a true inspiration to all of us. With immense pleasure and gratitude, I express my sincere and heartfelt thanks to you, sir.
Thank you, madam. Thank you.
Thank you, sir. The convener, Dr. D. Nida, put hard work and spent her valuable time in the preparation of the preliminary task of the program. With love and gratitude, I extend special thanks to dear ma'am for the exceptional efforts in making this event a great success. It requires planning and a bird's eye for the smooth running of such big programs. We are very fortunate to have a team of research scholars who are all worked together with exemplary cooperation throughout this week and helping the faculty members in all aspects. I feel proud of you, dear students. We will ever remain grateful to you all, dears. My sincere thanks to all the faculty members of our department for their active participation, constant help, and continuous support throughout the event. I extend my heartfelt gratitude to all the resource persons who were all enlightened us with their presentations. A wide round of applause and lovable thanks to all the participants who made the event a memorable one. Let us all have a wonderful lifetime in future. Thank you all.
Okay, thank you. Thank you all.
Once again, I thank all of our participants for their cooperation through this week and their support for our team. Now, certificates will be issued to all participants who filled out the feedback forms. Kindly remain in the group until you receive your certificates. Certificates will be issued within 2 weeks. Thank you. Stay tuned with NMCC Mathematics Department. Thank you, Vanessa. Thank you so much, sir.